Okay, so I'm going to finish the review for the first exam in this video. So I'm going to start where I left off in the previous exam review video. So the next question was asking us to graph this function, f of x equals negative x squared minus 2x plus 3. So on a graph like this, or on a question like this for your exam, they would probably give you multiple choice, and you can graph this using a graphing calculator and then compare. Or if they wanted you to actually graph it on a graph, then you can also use your graphing calculator and find some points on the graph. So that's what I'm going to show you how to do now on the graphing calculator. Okay, so if you have this calculator, you will go to y equals first, and it was negative x squared, so I need to push this negative sign down here at the bottom. Hold on, I don't know anything. Okay, so sorry. All right, so this negative sign at the very bottom, it's highlighted in red now. Whenever you start a function with a negative, you need to click that negative sign instead of the other one. And then I will click on the x squared. And then it was minus. My iPad is not working very well. Minus 2x and plus 3. Let me just make sure that was correct. Minus 2x plus 3, okay. Okay, so then once I have this entered into my graphing calculator, I'm going to hit graph. And this is what my graph will look like. And so I can find 3 points on this calculator. I can find the x-intercepts, which there's 2 of. One over here. Sorry. Right there, and then the other one is over here. So I can find those 2 points either by going to the second graph and going to the table, which might be easier. So when we're at an x-intercept, y is equal to 0. So right here it says y is equal to 0 right here, so that gives me 1, 0. And I know the other one was on the negative side, and here it is right here, because here's the other y equals 0, and so that would be negative 3. And that makes sense because that's what it's counting by, scale of 1. So the one on the left is negative 3, and the one on the right is 1. Or you can go to second trace. Man, my iPad's being weird. Okay. You can go to second trace and then go to 0 and hit enter. And then bring your cursor to the left of that first x-intercept and hit enter, because it wants a left bound. And then move it to the right of that x-intercept and hit enter, because it wants a right bound, and hit enter one more time. And there we've just confirmed that that 0 is negative 3. And then the other one, oh my gosh. I go second trace again and go down to 0 again. Move it over to the left of the next 0, which would be a little bit above. Hit enter, move it to the right, hit enter, and hit enter one more time, and that gave me positive 1, like we said. So let me just go ahead and write those down. Oh my God, sorry. or plot them since it wants me to graph. So I found the x-intercept of -3. Just right here. And then the x-intercept of 1, which is here. So that's just the first 2 points. I would either plot on the graph or compare with the graphs that they give me. And then the next thing I could do is find the relative maximum point, which remember is the top of the mountain. So it looks like there is a relative maximum around right here at the top of this parabola. And to find that value, I can go to second trace again. Let me start that over. Okay, second trace and then go to maximum because that's a relative maximum value. Hit enter and then it wants a sorry, I don't know what's going on. Let me close some tabs. Maybe I have too many of these open. And I guess I closed the wrong one. So let me enter this in real quick. Okay. Okay, so again, I'm going to go to second trace and go to maximum. And it wants a left bound, so I'm going to bring my cursor to the left of where I think that maximum point is. Hit enter, and then bring it to the right. Hit enter, and hit enter one more time. So remember I'm going to write down this point, but in this point, the negative for the x value, -1.00001, I'm going to go ahead and just round that to -1, because if your calculator gives you a value that's really, really, really close to a number, it probably just means that it's that number that it's close to, which is -1. So I wouldn't include all of those decimal places with the zeros. So that point would be the point -1, 4. Which would be right here. And so I have enough information to graph this graph. Looks like this. And that point was -1, 4. This point was -3, 0. And this point was 1, 0 that I used my calculator to find. So that's the graph. Part A wants us to find the domain. So remember, the domain means all the possible x values that are going to be on this graph for each point. So because this graph is going forever in the left direction, because of this arrow, it's going to keep going forever and ever and ever and ever and ever this way, and it's going to keep going forever and ever and ever to the right. That means that no matter what x value I think of, it will have a point on this graph associated with it. So the domain is from -infinity to infinity, positive infinity. All x values are going to be on this graph at some point. The range, however, if I look from the bottom up, since it's going down forever, I know that that will go down to -infinity. And you always want to start from least to greatest. That's why I'm starting from bottom up for the y. But the largest y value that you see is that +4 at the maximum value. That's as far as the graph goes going up. So that would stop at 4 with a bracket. because 4 is on that graph as a point. So it's included. So this is for part A. Part B says to give the intervals for which the function is increasing and decreasing. So if I look from left to right and I follow my graph, it's increasing because it's going up all the way until that point, which is the maximum value point. So the interval, which is the x values for which this graph is increasing, that would start from negative infinity. And it would stop increasing at that x value of -1 that we see there. And these always get a parentheses for increasing and decreasing intervals. And then for decreasing, still going from left to right, starting at that point, now I'd be going downhill. So it's decreasing from the x value of -1 to positive infinity, since it's just going to keep going in that direction forever. So that's the interval for which it's decreasing. And then for C, the relative maximum and the relative minimum values. So there's only a relative max, which we found to be 4. So the relative maximum value is equal to 4. That's always the y value. And then they may ask you where it occurs. Which is x equals -1. Okay. So that's that problem. And then the last problem on this section, and I have one more section after this problem. We're going to be doing a lot of the same things we just did, but this time they're giving us a picture of a graph, and they want me to answer the parts below. So first thing they want me to figure out is the domain and the range. So again, because this function's going forever, it's going to be going forever to the left and forever to the right. This domain would be -infinity to infinity again, because there will always be an x value associated with some point, no matter what x value you pick, because it goes on forever in the left and the right direction. So the domain is from -infinity to positive infinity. And so is the range, because the range, the y values, starting from the bottom up, this is going down forever. So it's going to keep going down. That means any y value will be on that graph somewhere. And it's going to keep going up forever. So any value for y you can think of, there will be a point that has that y value on this graph somewhere. So the range is also from -infinity to infinity. And then B says, for which intervals is the function increasing or decreasing? So again, if I'm going, if I'm going from left to right and tracing this graph, I would be moving uphill up until that point. So that's one interval for increasing. And that would be from -infinity to that x value. Oh my goodness, this is not working today. It's driving me nuts. Okay, here we go. That x value is -0.667. And then it would be, if I kept tracing it from that point, well, now I'd be going downhill until I got to that point there. And then I would start walking uphill again. So I have another interval for increasing, which starts at that x value of 2 and goes to positive infinity. So for the increasing and decreasing intervals, it's always over the x values for which this is occurring. So that would be for the increasing intervals, and then for that one interval of decreasing, that would start at the x value of negative 0.667 and then go to the x value of 2. Okay, and then it says the function's relative maximum value is blank. So remember, relative maximum, these are the tops of the hills. So that would be this point at the top of that hill. And the actual maximum, relative maximum value is the y value. So that would be the 2.37. And it occurs at that x value negative 0.667. And then the function's relative minimum value, these are any like bottoms of the valleys. So that would be this point here. The y value of that point is 0. So that relative minimum value is 0. And it occurs at the x value of 2. And then D wants us to find these three function values. So the first one is f of 0. And remember what this notation means. It means the y value when x is equal to 0. Because that is the x value there in the function notation. So they want me to figure out what is the y value on this graph when x is 0. So I go to my graph, I find where x is equal to 0, which is right here in the middle. And then I see where that lines up with my graph, which would be right here. And that x value is 2. So f of 0 is equal to 2. The next one is f of negative 2. So same thing, finding the y value when x is negative 2. So x is negative 2 is right here, and that's right on the graph. So that is f of negative 2. The y value there is actually equal to 0 because it lines up with the y value of 0 there. So this is equal to 0. And then finally, f of 4. Here's x is 4. So I'm going to line that up with where my graph is, which is right here. That's where it crosses. That's where I have a point on my graph that has the x value of 4. And the y value there is 6. Lines up with 6 here. So f of 4 is equal to 6. Okay, so that's going to be the end of that first file that you will see posted. And now I'm going to go to the second one. I am going to skip these first two, solving linear equations. If you do want me to go over these with you, just let me know and I'll do a Zoom call. But they will be filled out on the notes when I post them. But I want to focus on the harder problems. So this third question says, find the slope if it exists. So we need to remember what kind of line this is. And these are notes you can have on your flashcard. If you remember, x equals some number, and I'll write a, any number. This is a vertical line. And y equals some number, this is a horizontal line. So we need to remember that. And if I wanted to graph this, it says x is always equal to -3. So I would find -3 on the x-axis, 2, 3. And if I would have a point there, because it doesn't matter what y is. And then to find another point with an x value of -3, since it always has to equal -3, I would either have to go up or down. Because if I move right or left, I'd be changing x values. But both of these points I have here also have an x value of -3. So this is a vertical line. And vertical lines have a slope that is undefined. So this is just a note you can have. So the answer would be an undefined slope. And if it was a horizontal line, then the slope of a horizontal line is 0. Okay, the next one I'm going to go over. I'm skipping this one because I already did one like this on the last video. But this one says that a person buys a phone for $95 and signs up for a single line phone plan with 3,000 monthly anytime minutes. The plan cost $115.65 per month. Write an equation that can be used to determine the total cost of this phone plan for T months. Then find the cost for 24 months, assuming that the number of minutes that person uses does not exceed $3,000 per month. Okay, so they want me to write an equation that can be used to determine the total cost C of t. So they're saying this is going to be the name of my function, the cost, and it's in terms of t, which is the total number of months. Okay, so total cost. So I have to include how much they paid for the phone because that is also included in the total cost for this phone plan. They had to pay that right off the bat, just one flat fee of $95. And then we would add the $11.15, and let me use some colors. $11.15.65 per month. So $115.65 per month. So this is what I have to pay every single month. So the total cost for this plan, depending on how many months I've had it, I would have to add that $115.65 times T. Because this is going to tell me the total cost after T months. So if I've had it for 3 months, I'd have to multiply that monthly payment by 3 to figure out how much I've paid up until that point. But the 3,000 monthly anytime minutes, this is kind of just extra information. The plan has 3,000 monthly anytime minutes every month. That's just what the plan comes with. So we're just creating a equation for the total cost of this plan. So if she goes over, that's not included in this equation. We're not worried about that. So this is the equation that would tell me the total cost. The cost of the phone, $95, plus the monthly payment for each month. And then it wants me to use this equation to find the cost for 24 months. So now I'm plugging 24 in for t, which is the number of months. So that'd be C of 24 equals 95 plus $115.65 times 24. So doing the multiplication first, 115.65 times 24, and then adding that to 95 gives me $2,870.60. So that would be the answer to the second part. Okay, next one says find the center and the radius of the circle and then graph the circle. So the standard form of a circle is given by x minus h squared plus y minus k squared equals to r squared, where h comma k is the center of the circle and r is the radius of the circle. So this is the standard form of a circle. I guess I could include that. So this is something you could have on your formula sheet, flashcard. So if it's in this form, which this equation is up here, then I can easily identify the center and the radius. So because the original form has a minus in here, in its standard form, the number that I need to get for h would actually be the opposite of this sign. So because that is a positive 3, h would have to be negative 3. And k would be a positive 2. So the center is negative 3 comma 2. And the radius, since the form is r squared and r is the radius, I need to figure out what number is equal to 36 when I square it. R squared equals 36. So that would have to be 6. So the radius is equal to 6. 6 times 6 is 36. So now I can use this information to graph it. So I'm going to start with the center, which is the point negative 3, 2. So that would be right here. And then I'm going to count from that center point out 6 spaces from the top, bottom, left, and right. 2, 3, 4, 5, 6. That would be at 8. And then from negative 3, this would be negative 9. From 2, this would be negative 4. And this would be positive 3. So that is how I can find the points on the edge of my circle because the radius is the distance from the center to all the points there. I don't need those lines, but I was just showing you that. So that's how you would graph that in Pearson. Okay, the next problem we're going to do has to do with piecewise functions. So a piecewise function is a function that's broken up into separate pieces based on the domain of each piece. So for example, this function f of x is only equal to 2x minus 3 when x is less than or negative, or when x is less than negative 6. And then it's equal to positive 3 when x is greater than or equal to negative 6 but less than 2. And then it's equal to x plus 5 whenever x is greater than or equal to 2. So the first type of problem you would see on your exam is asking you to find function values of a piecewise function. So this first one says find f of negative 6. So that means I'm plugging negative 6 into the function. So I need to figure out which piece negative 6 falls into the domain. And that would be in the second piece here, because that says for values x that are greater than or equal to negative 6. So it can equal negative 6 in the second piece. And that's just equal to 3. So I don't need to plug it into anything because it's just a constant. So the answer there is equal to 3. The next one is f of 2 here. So again, I need to figure out which of these pieces does 2 fit into the domain. And that would be the third piece, because that says x is greater than or equal to 2. So it can equal 2 there. So now I would plug 2 into x plus 5, which would be 2 plus 5, which is 7. And then that would be the final answer there. The next one is asking us to find f of 0. And 0 would fit into the second piece, in the second domain, because 0 is less than 2 and greater than or equal to negative 6. So it's in between negative 6 and 2. And again, that one's just equal to 3. And then finally, we can find f of negative 8. So negative 8 falls into the domain of the first piece because negative 8 is less than negative 6. So for that one, I would plug in negative 8 into the x here, which would be 2 times negative 8 minus 3. 2 times negative 8 is negative 16, and negative 16 minus 3 is negative 19. So that would be the final answer for that one. Okay, the next one's going to ask us to graph a piecewise function. So remember, piecewise functions, they're broken up into pieces. So I'm going to graph each piece separately. So I'm going to start with here's the first piece. I'll break this up like this. So this will be my line 1, because both of these are lines. So f of x, or y, is equal to 1/4 times x whenever x is less than 0. That's the domain for that first piece. Second piece is equal to x minus 2. Whenever x is greater than or equal to 0. Okay, so to graph these piecewise functions, I'm going to start with the first line, line 1, in green, and you always want to start with the endpoint when you graph it. So in this case, the endpoint is 0 for that first piece. Now, even though it can't equal 0 in the domain, I'm still going to find the point, or I'm still going to find the y value when x is equal to 0 for that piece of the graph. And I'll explain how we graph that differently when it can't equal 0. But you always need to start with that number at the endpoint, which in that case is 0. And if it was like this up here, where it has 2 endpoints, I would need to figure out what's happening at those 2 endpoints. Okay, so let me make a little XY chart here. If I did plug 0 into this first line, 1/4 times 0 here would just be 0. So that would be the point 0, 0. But because 0 is not in this domain for line 1, x is strictly less than 0, this would be an open circle on my graph. And that point is at the origin, so that would be right here as an open circle. And then, so that's the first point. The next point I would get would be picking a value of x that's less than 0, because I need to pick a value of x now that's in the domain. And I'm going to pick the value -4 so that I can get a integer answer. Because if I plug in 1 or -1, that would be -1/4, and it's harder to graph fractions in Pearson. So I'm going to pick -4. And 1/4 times -4, this is just equal to -1. So this would be -1. So graphing that would be, let me use red again, -4, 1, -1, be right here. And then I would just connect these 2 points, but only going to the left, because again, I'm only graphing that green line for values of x that are less than or equal to 0. So that's the first piece. The second piece, again, I'm going to make an XY chart. And I'm going to start with the endpoint of the second piece, which is also 0. And when I plug 0 into that function, 0 minus 2 is -2. And so now when I when I plot this point, this would be a closed circle. Because 0 is in the domain there. So that would be 0, -2, which would be right here as a closed circle. Because it's included in that line and in that domain. And then I would want to pick a value of x that's greater than or equal to 0. So, which I already chose 0, so greater than 0. So let's say 1. If I plug in 1, 1 minus 2 is -1. So that would be 1, -1, which is right here. And then I would only be connecting those two lines going in the right direction, because I'm only graphing that second line for values of x that is greater than or equal to 0. And then I would be done. So on your exam, this one would have multiple choice answers. So you're kind of just looking at the multiple choice answers and kind of using process of elimination and making sure everything lines up right. Or do you have open circles where they need to be open, closed circles where they need to be closed, and are they graphing the correct points? Okay, 4 says, determine whether the graphs are symmetric with respect to the y-axis, the x-axis, the origin, or neither. So for the first one, this would be symmetric about the y-axis, because the y-axis, which is the vertical axis, cuts that red graph into two mirror images of each other. So that's the line of symmetry. So this is symmetric about the y-axis. The next one is symmetric about the origin. And I can tell that because if I look at a point, say this point here, which looks like it's 2, 10, because it's counting by 2s, 2, 4, 6, 8, 10. So that point is 2, 10. And if I look and try to find -2, -10, it would be on my graph. And all the points would be like that. So this one is 2, or around about 2 is kind of what it might not be exactly 2. It's kind of hard to tell. Is that one 2, 10? No, it's a little off from that one. Because if you look, it's like a little past 2 right here. This one, though, this one's definitely 2, 8. Oops. Okay, that point is 2, 8. And we have -2, -8 right here. And so this one's symmetric about the origin because all the points would have a corresponding pair that's opposite of each other. And this is also your base graph of a cubic function. This is from the cubic function, x cubed. These are always symmetric about the origin. Number 5 says, determine whether the given function is even, odd, or neither even nor odd. So remember, to test whether a function is even, odd, or neither, we need to plug in -x into the function. So this would give me -x all cubed plus 2 times -x all squared minus 8. When you raise a negative number or variable to an odd exponent, it remains negative. So this would be -x cubed. But this one would become positive because it has an even exponent. So that would be plus 2x squared minus 8. And then you compare. If it's exactly the same as the original function, it would be even. But we see that it's not because this one's negative. And this first term up here is positive. So it's not even because they're not all exactly the same, all the terms. And it's also not odd because these two are the same and these two are the same. So every single sign would have to change in order for it to be odd. So if those two in green had opposite signs, then it would be odd if every single term has an opposite sign as the original. But this is going to be neither. So it's even if all the signs are the same, if it's exactly the same, and it's odd if all the signs are opposites from the original. And if it's not either one of those, it's neither. Okay, and then the last page wants us to work with composition of functions. So this is a definition you can have on your flashcard here. And please remember to email me a picture of your flashcard before you go to take your test. But this says given f of x is equal to 2x plus 1, and g of x is equal to x squared minus 4x plus 1. It wants us to find f of g of x, or the composition of f and g. So by definition, the composition of f and g of x is equal to f of g of x, which is what this says up here. So this is just notation. It tells me to take g of x and plug it into f everywhere I see an x. So I could replace that g of x with x squared minus 4x plus 1 because that's what g of x equals. And now this notation, again, it's still just notation. This is telling me to plug in x squared minus 4x plus 1 into f. So this would be 2 times x squared minus 4x plus 1, and then plus 1. And then this would be, I would distribute that 2, so that would give me 2x squared minus 8x plus 2, bring down my plus 1. So this would be 2x squared minus 8x plus 3. And that would be the final answer there. And the domain of this new function is all real numbers because there's no restrictions on this function. There's no fraction and there's no square root. Okay, number 7 says, given that f of x is equal to x cubed and g of x is equal to x minus 6, it wants me to find f of the composition of f and g of 2. So this is the same thing as, notation-wise, this is the same thing as f of g of 2. Because it's the same definition if this was just an x. I'm using the same definition up here. So inside those parentheses where it says g of 2, that's telling me to plug 2 into g. So I'm going to keep with the notation. And replace g of 2 with what that would be, which would be 2 minus 6. Because g of x is x minus 6, so plugging 2 into g, which is what that tells me to do, would be 2 minus 6. And that is equal to negative 4. So now this notation tells me to plug negative 4 into f of x. Which would be negative 4 all cubed. Since that's x cubed, that's what f of x is equal to. And this would be negative 64. Now you could also find, let me write, or you could find f of g of x first, which tells me to plug g of x into f, which would be x minus 6 all cubed, and then plug in 2, which would be 2 minus 6 all cubed, which is negative 4 cubed, which is negative 64. So either way you want to think about it, you could do it either way. And the last one says, given that f of x is equal to 3x minus 1, and g of x is equal to square root of x, find f of g of x and g of f of x, and then find their domain. So f of g of x tells me to plug g of x into f everywhere I see an x, so this would be 3 times the square root of x minus 1, and I can't do anything with that, so that's just 3 times the square root of x minus 1, just as it is. Now the domain of this does have a restriction. Because I have that square root there. And the restriction on the square root is we can't take the square root of a negative number. So that expression underneath the square root, which is just x, this needs to be greater than or equal to 0. And this is in fact the domain. Because it's already solved for x. So x is, or the domain is from 0 with a bracket to positive infinity. And then the next one is g of f of x. So now we're going backwards. Now I'm plugging in f of x into g, where I see an x. So g of x is the square root of x. So instead of x, I would have 3x minus 1. And that would be it for that. And now to find the domain, I still have a restriction for this one because I have a square root. So the restriction is that entire expression underneath the square root, 3x minus 1, has to be greater than or equal to 0 because it can't be negative. So I need to solve this inequality. So I would add 1 to both sides. And divide by 3. So x will be greater than or equal to 1/3. And an interval notation, this would be starting at 1/3 with a bracket to positive infinity. Okay, so if you are still unsure about anything or worried about any type of problems for the exam, please don't hesitate to reach out to me. We can set up a Zoom meeting before you take it. Just let me know. I'll have plenty of time. And we don't have school tomorrow on Monday, so that should help you get caught up on your assignments and study for your exam. And to make sure you take that practice exam as many times as you can. That is the best way to study for the exam. And also, if you have not made an appointment for the testing center, if you're in my online class, make sure you do that or you'll miss your chance to take your first attempt. Okay, thank you guys. Have a good day. Please let me know if you have any questions.